Hey everyone, before we start the episode, I just want to give you a real quick update about some changes to the podcast coming up. This month, the month of April, we are starting to edit the podcast ourselves, which means we're not really doing much editing at all because we don't have time to do that. We really appreciate the editors that we've been paying to do this, but it's not financially possible for us to keep going with it. I am not a professional. There are a lot of tools that help here, but it still takes a lot of time to do this. So starting April, like I said, we are going to finish out the month with weekly episodes that we are going to edit, and hopefully everything sounds okay, or at least good enough. After April, we're actually going to be shifting to a monthly cadence for the podcast. That's just to save on the time. We are already shifting to save on finances, but doing editing and recording every week is not possible for Autumn or myself. And the biggest downside to that is just we have so many fantastic guests that we want to talk to, and it's not going to happen at a weekly cadence anymore. So it's not to say that we're not going to ever change it back. If we do start getting sponsors or do start getting ability to do weekly episodes again, we would love to do that. But for now, we're finishing out the month of April, weekly episodes, and then going forward, we're going to have monthly episodes. We haven't really decided which day of the month we're going to be doing that, but we're going to switch to like a waterfall method of deployment. That also means we won't be doing the live episodes at the end of the month, which were really fun for us. We liked having the games and sort of a news episode, but in this case, it's just not going to work out if we're only putting out one episode a month. So for now, we are just going to split to one standard interview every month. We have them all planned out for the rest of the year. It's going to be great. We are still excited about the people we get to talk to and the things we get to talk about, but that's just a change that's coming up. So I want to let everyone know, again, thank you everyone who's donated to the show. Thank you to our sponsors. Thank you everyone who's listened. It's really been a lot of fun. We didn't want to put the show on hiatus and stop doing it. We just knew that we couldn't maintain what we were doing for the first 3 months for the rest of the year. So those are a couple changes. We're really looking forward to this show. It was a great episode with Jake, all about different things than I thought. Let's go ahead and just jump into the episode with Jake. Welcome to Fork Around and Find Out, the podcast about building, running, and maintaining software and systems. Hello and welcome back to Fork Around and Find Out. I am your host, Justin Garrison, and with me is Autumn Nash. And today on the show, we have Jake Cooper, founder of Railway.com. How's it going, Jake?
It's good. It's good. Just getting over a cold, and we've got a launch week next week, so it's just like kind of chaos internally. I just realized Discord was still going, and I was getting pinged, so I was like, all right, let's close that down. So I'm really happy to just like take a second, take an hour, and chat about this, and then back to the Thunderdome, basically. So it's a lot of exciting stuff.
How old is Railway?
Railway's about 4.5, almost 5 years. It'll be 5 years old in June. Yeah.
And so, why did you start it?
I just thought like I was consistently kind of a little bit disappointed with most cloud infrastructure, and I thought it could be like significantly better. And so the goal was to just make significantly better cloud infrastructure, right? Like infrastructure that just kind of works with you instead of, you constantly having to go back and reconcile it and, just try and really, really scale through it. It should kind of just like move really, really seamlessly. And so that's what we wanted to build, and that's what we've been trying to build for the last 5 years. Yeah.
And you picked GCP?
Yeah, I know, right? I was like, it was one of those things where I was like, kind of new AWS, and we were like, oh, we could do that, et cetera. We had a few calls with the GCP reps originally, and it was well sold, et cetera. They give us the best pricing. We're like, okay, well, we're going to use a lot of compute in general. Like if we're going to start a cloud, so we did go with them, and then we've slowly gone with our own bare metal infrastructure as we've kind of like moved a bunch of stuff off of them. So yeah, it's been a very, very interesting journey for sure.
I was just mentioning, I just reread the So You Want to Build a Data Center blog post. We'll link it in the show notes. All about some of your trials there and in multiple outages and various things that you had problems with GCP. Not only just the standard of like you're reselling cloud infrastructure, and so your pricing is based on their pricing, and any margin you can get from that, including egress fees. Yeah. Why do you think that you had these problems in folks like Heroku are on AWS and have been for a very long time.
So I think we're trying to jam a lot of instances, like thousands of instances onto these VMs, right? And so at a certain point, like you end up running into like reasonably sharp edges that exist in kind of like either the virtualization or like actually just like the underlying like cloud platform itself. So I think at some point, whenever you try and push the edges on a lot of this stuff, you like things just tend to break, right? That's kind of like the nature of stuff, right? Like if people are giving you standard kind of like off the shelf stuff and you try and go do non-standard off the shelf things, you're going to kind of run into these edges, right? And Heroku, I think historically has used mostly AWS, so maybe this is not a kind of a non-issue in general for them. But at least for us, we kind of ran into like a few of these various different issues, and like there's probably ways to like get around them on these machines, but at some point it just ends up being you're spending a lot of your time trying to like build these workarounds or kind of like build resilience into the cloud platform. And at a certain point, you might as well just like actually take advantage of the fact that most hardware like that comes out recently is actually like higher order reliable, right? It's got, dual redundancy, everything. It's way more reliable. Recently, like statistical failure of like machines is actually like significantly lower now. So at a certain point, it actually makes sense if you want to like take that leap. And kind of like, as you mentioned previously, there's a lot of different kind of things that you are beholden to when you are like building a cloud on top of another cloud, right? Obviously the margins, but even something as simple as like the egress, right? Like we just kind of have to pass that on to our users, right? And we have to charge them the like kind of cloud, twist my wrist level of like egress charging, right? I know like Cloudflare is that like awesome like bandwidth alliance, right? And so now that we're off of kind of GCP generally, then we can now go and do things like that. So I think it'll be really, really awesome. We can do a lot of really, really cool stuff with like lowering the price of especially egress, storage, maybe compute in the future. We have a few announcements on that next week. So
yeah, and I think that one of the things that the cloud did is just they started charging for things that people didn't get charged for before, especially egress, right? It's just like, oh, egress was this thing that was like, yeah, you have to set up the connects. But after that, like the bandwidth is free essentially. It's like I pay for the uptime. So I'm not being charged from my ISP or something on how much bandwidth I'm consuming.
yeah, the link is there whether you use it or not, right? So yeah, it just ends up when you have multi-tenants, et cetera. You got to meter it. You got to figure out some way to go in and do that. And charting ends up being a really, really good way to go and do that. And then on top of that, people want to keep their data. Cloud providers want to keep their data within their walls, right? Like data is kind of the kind of like gravitational well that kind of like keeps your application around it, right? So that it kind of just makes sense from their perspective to charge for it, but it's really, really nice now that we just don't have to go in and do that.
In keeping the data within the walls, like you mentioned, I mean, you are now a cloud provider and you may also want to keep data within your walls, but I feel like you are competing on different level. Like you're just like, oh, you know what? We're just gonna make it better to do some of these things than what you and better in a sense of for developers in certain scenarios. You're not doing some of the crazy, multi-peering, hundreds of accounts, sort of like enterprise needs weird things and they need all the flexibility in the world. They just want a virtual switch. And you're like, no, we're not giving you a virtual switch. We're giving you infrastructure applications, right?
Yep. Yeah. So there's like, there's a couple of things there, right? Because like, I think we want to compete on different merits, if that makes sense, right? And so if you have data gravity and you have like egress fees and all of these other things, you're almost like competing on the fact that it's like, oh, we already have this. And so we have this kind of like moat advantage of just already being there, right? And for us, we think about the fact that if we make things trivially easy to deploy and move and all those other things, then like we can actually have people ship quicker, right? And that's kind of our mode in general, right? It's like we just make the software way more easy to use, and then you will use it, right? And if we do our job correctly, you'll want to move towards it. And if we do our job incorrectly, you will want to move away from it, right? And there's no lag in terms of that information, right? Because it's reasonably easy to migrate after a certain point, right? So that's kind of like a double-edged sword that we have, but we really kind of like lean into it because we want that information as quick as possible, because if we're not doing right by the users, we want to know, right? We don't want you to be there and like be beholden and like super pissed about your cloud provider, but you can't move because of, egregious, complexity or cost or any of those other things, right? You want us to tell us, and then, at some point we want to actually see like, oh, there's smoke over there. Like, let's go fix that.
How do you keep it sustainable?
Do you mean from a, workload insanity perspective, or do you mean from like a cost and
Both kind of, because I mean, at some point, there has to be a way for you to run all this and employ people at that scale to do it right.
Yeah.
So that to a certain extent, more enterprise, like at some point they're trying to make more money, but also like it's running the technology. So like, how do you keep it this as you scale sustainable without charging for egress and all these things?
Yeah. So the way that we work is we actually like will pack thousands of these instances together, and you only pay for your usage, right? So instead of like going in and acquiring those like kind of massive margins where AWS is kind of like oversubscribing their instances and like selling multiple 4 gig boxes on top of each other, we're actually just going to go to our users and say like, you just pay us what you're actually using. We will only charge you that fairly. We'll charge you more per like vCPU or per dollar, but we will actually go and optimize your on top of your usage to only bill you for those things, right? So the sticker price might look higher, but in reality, it ends up being about 30% cheaper, right? And then in terms of like actual margins, this is why it becomes very, very difficult to like build a cloud on top of a cloud, because there's only two options, right? You either shaft your users by basically putting everything behind an enterprise paywall, or you go and figure out how to solve these like hard technical problems and then like go and pass those savings onto the users, right? And we've decided to go and do the latter. And that just means that we get to like solve really, really hard engineering problems, which are like, they're interesting, they're difficult, but they're like ultimately like quite rewarding and quite fun, for engineers to go in and solve. So that works quite well for us, right? And then we have a fully remote distributed team. So that works really, really well from like a on-call perspective, delegating work, right? Like I work with a person in Thailand and, I'll like wake up and they'll be going to sleep and they'll be like, hey, can you do this? I'm like, yeah, sure. Right. And then, they'll go to bed and then they'll wake up and in the morning I'll have done the thing. Right. So you almost get like twice as many hours in your day, if that makes sense, if you can kind of like sequence the work really, really well. And then it's,
what do they call that? It's following the sun on call. Or
yeah, exactly. Right. So we can do follow the sun on call really, really, I don't want to say easily because it's never easy or whatever. But like not impossibly, right? Because we have a fully distributed team, right? So there's a few different things that we do that make it reasonably tenable.
You mentioned. Go ahead.
It's just nice to hear someone saying the positives of a distributed team, because that's always what, like there's some, like I remember looking at teams within AWS and the people that would have one team in the US and one team in another country and they would do follow the sun. I was automatically like, yes, because that your on call is not going to suck, like it's so interesting to see that people are so against like remote work and stuff. And I'm like, this is it makes things so much better. Like we're going to pretend like not having people in different time zones doesn't make your life so much easier, because it does.
Yeah. And it does in so many ways, and then it doesn't in so many other ways, right? Like we have an entire class of people that are like very, I would say, difficult to hire at Railway because we're fully remote, really early stage, like 25 people, and like people who are going to be successful in that environment are like high agency, high autonomy kind of archetypes, right? And so if you have people that like you'd love to mentor them because they seem like awesome junior talent, but like if you're not like there to like unstick them or anything else like that, it means that like they're sitting there, they're waiting, right? And so that ends up being a kind of a very, very difficult thing for us to like potentially go in and do. So we basically said like we're really only going to hire like senior staff like talent as of right now until we get like everything kind of off the ground, and then maybe in the future we can kind of like do more mentoring and stuff like that. So there's obviously massive benefit, but there's also kind of like a massive, I don't want to say cost, but like you gotta design for it organizationally, right? I put a blog post out the other day. I think that I was saying that like, despite running a remote company, I think like 90% of companies are probably better off in person because they're not willing to like put in the organizational effort to like make the organization work in the way that it would need to work well remotely.
I think it depends, right? Like I think people were working remotely for years, and it's definitely harder when you're a junior, but there's whole schools that teach like development, and there's whole apprenticeship programs and like nonprofits that do that and can ramp people up remotely. So I think it's more of figuring out a good way to onboard people remotely and kind of champion that and making mentorship.
helping, the mentorship, like the ongoing relationship with people on the team. Cause I mean, 50% of the people are below average, right? Like just like how that works. So it's like, like those that 50% might need help with things. And that includes your managers, right? Like your managers also, half of them are going to be below average. And if you're saying like, we only hire the top quality tier, like, well, 50% of those people are still below average in your group, right? And so you have to just like, how much do I need to mentor some people? How much do I need to let people just go and do their own thing? And I think what you're mentioning, like the follow the sun sort of like work handoff works really well as long as the team are kind of aligned on the same goals and they can unblock themselves for things and they communicate well. Because a lot of people that work great in the same time zone need to work well by communicating in person. They need to talk to someone and say, hey, how are we going to fix this? And we need to brainstorm it. They can't go off and think on their, not that they can't think on their own, but maybe they can't get around a problem without having someone to rubber duck with them, right? Like that is a problem.
Which I mean, like, I love a good whiteboarding session in person, but in reality, I don't even think a lot of that work gets done in the office. If you look at all the time that you spend distracted and it's noisy and all of the other parts, like, honestly, I think it's because we have gone so many years kind of developing the process in which that we do that mentoring in real life. And we went into COVID and a lot of companies went into remote work kind of like out of necessity, and it wasn't something that we planned for. And we weren't thinking about how you get like, an engineer from new to senior, right? So it's like really easy to just hire seniors, but we're not going to have enough seniors left over if we hire juniors. So I think we've got it's going to be very telling, like going forward, who ends up figuring out that piece of how to onboard and grow junior engineers remotely, because that's going to set a lot of startups apart.
Yeah, I think remote is kind of like, there's a lot of really good like arbitrage inside of remote, right? And so if you can do things like, if you can run a high performance team leanly and remotely, excellent. If you can onboard people like really, really well, get them up to speed really, really quickly, excellent. If you can mentor and grow junior talent remotely, excellent, right? Because a lot of like, most companies are just going to be in person, right? They have the kind of standard operating procedure, like the kind of like almost a McKinsey derivative playbook of like, this is how you manage and this is how you onboard and this is how you do X, right? And they're kind of like almost benefited to doing that, right? Because like they know it works, right? And so,
what's funny is I don't even know if it works for most people though. With the amount of neurospicy people in engineering and in tech, being on an engineering floor and all that noise, like I think it works for some people. But those are just the people that have survived for a really long time,
Yep.
And I think
it
it's
works
actually
for the people that made the training.
Exactly. And I think it's like very actually counterproductive to the like overall masses. And those just happen to be the people that designed it. It worked for them and they kept going.
Yep. I mean, I fully agree. I worked remote for like, I probably like the last 10 years total. Like I think Uber was pretty much the only company I worked not remotely at, and I lived beside the office. Like,
did you like Uber?
Yeah, I liked Uber a lot. It was great. I lived right beside the office though, right? And so people would be like, "Oh, you're not at your desk." I'm like, "Yeah, I just went home. It was 2 blocks away. If you want me, I'll come back." But I'm gonna go work in here.
I went to the bathroom in my bathroom. Okay.
Yeah, in my bathroom. Yeah.
Going back to what you said earlier about competing with clouds and stuff and handing off the value that you get to your customers. Was there things that you could do now that you moved to your own hardware and your own colos that you couldn't do on Google or in eCloud that you're like, hey, we're just letting customers do this now?
Yeah. So, I mean, good example is that like the egress stuff, like, I guess whenever this podcast, like it'll be announced, like we're slashing the egress pricing next week, right? So like that's getting cut immediately in half. Right. So there'll be other things that we can go in and do. Storage is getting cut by like 40%. That's also coming out next week. We're knocking all of the seat costs off of, compute. Basically, like pretty much anything that is not like raw compute now, like that's really the only thing we need to go in and charge for, right? Because now we actually have like cheaper raw compute, right? It ends up being cheaper when you go and buy the hardware yourself to actually go in and build this out, right? Obviously, you got to build the software and the colo and all these other things, right? But dollar for dollar, it ends up being cheaper that we can pass on to the users. So that'll be like some start of it, and then we'll have like like terabit level like lines to be able to replicate data across these instances, and like 100 gig plus lines between these instances that already exist. So people are going to get like ultra fast network, ultra fast processing. They're going to get like better compute for a cheaper price, right? And like I don't know who does that, right? Like that's what we're trying to do, right? Like we're trying to go in and push those like boundaries on those edges and just remove any kind of like additional cost that we would, say like, hey, like let's charge you an arm and a leg for RBAC. Let's like charge you an arm and a leg for all of these other things, right? And let's just say like, well, we are benefited by the fact that if you just consume more compute, and we are the most reasonable compute price on the block and the fastest way to go and do it, then we're going to be successful and you're going to be successful. So let's like take away all the other bullshit. Let's stop charging for any of that. And let's just try and figure out how you can deploy more compute, right? Because then we're both going to win.
And you mentioned in the blog post about building your own data center, like this was like a January 2024, and then 5 months later you had your first computers turned on, and it was like 8 or 9 months you had customers using it. That had to be a big decision going into it, right? Like you were building and running stuff for a while, and you're like, we have to move and do this thing that's going to take a lot of time. And at a 25-person team, maybe even then you were less than 20 people. Like you were dedicating,
I think we were like 18 people or something like that.
Yeah, you were dedicating a good percentage of your company to say this is important for us to do. Just take a step back and do this. Like, what was the actual driver and push to like say we have to make this decision now?
I think there's a margin component, and there's also just like a almost like I would say like I don't know, psychology of the org. Like we look at like what is the next hardest problem that we have to go and solve, and then we try and figure out how to solve it just like as quick as possible, right? We're like, are we going to run out of money if we go in and solve this, and like what's the unlock if we go in and make this solution, right? So for us, we had a bunch of runway because we're reasonably capital efficient, small team. We weren't like running. We don't do any like marketing or anything else like that, any like paid marketing and acquisition, right? So like we have reasonable runway, so we were like, well, if this is the number one thing getting in our way, right, and we just like at the drop of a hat, and we like get paged because something happens on the other side that we can't control, like we have to be able to control those things, right? So we just knew that it was a thing that we were going to go in and do. Candidly, I knew like basically since the start that we were not going to be like on top of another cloud, because again, like the margins don't work, the incentives don't work, right? Because at some point AWS's margin function kicks in and they say, it's a really nice market you have over there. I'd really like to take that. And then like
I've always wondered how Heroku did it, because
I mean, Heroku's expensive, right? Like if
Heroku's expensive, and they're only doing about $1 billion in revenue as of right now. And so like the margin function may kick in, right? So it's tough there, right? But at a certain point, that function does kick in, and they will want to like produce something in that area, right? So you have to kind of go in and do it for margin incentive reasons, and then also the experience that we wanted to offer, right? Like we just knew that like we needed faster hardware and higher order control to be able to make these experiences that we wanted, right? Like even something as I don't want to say as simple as, because it's like very, very hard to go in and do, but doing like PR environments with your data. So if you fork into a new environment, like you may actually want to just like use your production data, but with copy on write versions, right? Like we can't do that on a public cloud, but we can do that on our like block storage instance that we have gone out and built, right? And that's like a differentiated experience that we can now offer because we are now on top of our own instances, right? So stuff like that, it means that we can go in and push those experiences onto the customer to be like, hey, this is differentiated. And if anybody else wants to go in and copy that, they have to go build all this stuff, right?
What would you say to the classic line of undifferentiated heavy lifting?
What do you mean?
That's the tagline that Amazon says,
that is
you shouldn't have to do this yourself. We will build you. We will run your data center for you. Don't do the undifferentiated stuff.
Yeah,
I think stacking network, whatever.
I think it's an interesting line, but like most of DevOps is undifferentiated lifting. You're doing a lot of stuff to just like get things off the ground, right? In just various different ways, right? So I think it's something that sounds reasonably solid, but you end up having to reinvent a lot of these things anyways, right? So they may be able to offer it, but the thing is if we offer it in a way that's like easier to use, faster and cheaper, then like we do have a shot at being able to give that experience to customers where they can just say, all right, cool, let's just use this.
After spending 9 months or whatever to shift to your own hardware, did you find that you had other time that you were getting back that you weren't doing, that you're like, oh, we used to do You know, these 5 people did all Terraform all the time, or they had to do this stuff to like manage GCP spend or some cloud environment, and now they just don't have to because it's just hardware, and we know how to manage that side of it. Was there any savings there, time?
Well, the savings are basically like we've made capital expenditures, and like those capital expenditures are now on the table, right? And so like so long as we have those things there, like we're not going to turn around and be like, oh my god, like where did this $50,000 GCP bill come from, right? It's because we have the hardware, right? Like either we're going to run out of hardware or we're not going to run out of hardware, right? So the like projections of your margin, it makes it significantly, I would say, easier on that side. Obviously, you have to do the upfront planning, but on the back side of it, right? Like it's a lot more controlled, which is awesome. And then just in terms of like operational overhead, so far it's been lower operational overhead to like run these instances because everything has dual redundancy and we have monitoring and alerting. So if a drive goes out, et cetera, we have like smart hands that will go in and replace one of those drives within like, I think it's like 6 hours or something like that. So it's like super quick. And then we have somebody within about an hour of every single data center in case like something really hits the fan. But everything is dual redundancy, right? So that's why we've built everything out.
So are you actually running your own data centers, or are you running a hardware inside of someone else's data center?
So we're running colos. We got in trouble for this on Hacker News, where we like have our own colos. She was like, so you want to build a data center? And the first time I was like, this isn't a real data center. We're like, fine, you know, right? But it's like,
can you explain to people what a colo is? Just because some people have only worked in the cloud, right? So like, I think, because like, I think abstraction is getting to the point where like, it's really hurting how people look at things, right? Just because you don't have to put something into AZs, or just because you've never done this, like the fact that we don't all understand those things, like, you know, like there's a lot of people who may have never even worked in, you know, like with data centers and on hardware. So just explaining that might help.
Yeah. So the data center, you can consider the data center as like the big building with all the power and all the Ethernet, et cetera. And then a colo is essentially like some amount of racks inside of that building, right? So you know, Equinix is a kind of data center provider. They will handle your power running into there. They will handle like internet hookup lines, right? So if you want to go to like Aurelion for like internet or anything else like that, they will handle the plugging in of those things. And they will handle like things like routing cables to a cage, giving you biometric, you know, stuff like that. So it gives you kind of like your own mini data center inside of a data center. And that ends up being like a co-located rack, or what people call a colo for short.
Do you ever worry though, because cloud was cheaper at first because they were trying to get more people there and it was this new thing, right? And then they had all of this, like, you don't have to worry about hardware, you don't have to replace it, we'll do that, right? And then like drives and just hardware and doing that got cheaper because people weren't doing it anymore. And then people were like, you can have your own data center and we'll run it for you. But what happens when those services become more expensive? You know what I mean? Because it's also like what's popular, what people are using, right? So that also has some play. Do you worry that if the fees for that, like, because I mean, if you had to run these data centers and you had to hire the people, that would be more expensive, right? And if you have to actually go and have DBAs or have people running your servers and replacing racks and stuff.
So I think there's two things there, right? Like there's almost like technological prowess to like go in and manage the instance itself, and then there's the almost like manufacturing prowess to like go in and make sure that you have enough like drives like showing up at some point, right? Because it's like, oh, okay, cool. If we don't consume drives, then we won't produce them in such capacity that like they will get more and more expensive over time, right? It's just the opposite of economies of scale or whatever. So I think the thing that I sort of worry about, but I don't worry about it so much as I think it is like actually another pretty good like our point of arbitrage is almost like the skills to manage those data centers, right?
That's what I've definitely.
It's kind of like a dying art, right? It's like people who commit like Linux kernel code or stuff like that. It's like those people are, you know, you don't have like 21-year-olds, right? Or at least those the exception, right? So it's like people who've kind of like accumulated this knowledge over time, right? And so for me, I almost more think about it as like, oh, like we got to preserve this. Like we need people to understand like how we can actually like go and manage these things. And if we can go and do that, and we can make advances in that field that's like potentially getting more and more sparse as like, you know, AWS or GCP or whatever just scoops up every single person, right? Then like we have a potential advantage of the fact that like this field is almost like not getting as many reps in as possible. And so we can potentially find, and we have found pretty like higher order efficiency gains just by doing things a little bit differently. right?
I see what
So,
I
Being
think.
differentiated helps your business.
Well,
Right.
I think that I totally get like the way you made your decision, like the fact that people try to build clouds on clouds just blows my mind knowing how much cloud costs, right? But it's just interesting because everybody was like all in on the cloud and they like loved it, and then now everybody's all in on on-prem, but it's just like look at how it ebbs and flows when it's like what's how much cheaper storage got at one point, and just it's because people aren't using it as much. And like DBAs were having to get jobs working as SAs for databases because nobody was using DBAs because they wanted to get like managed databases. So it's like this weird flow, and it got to the point where the big companies were having apprenticeships because they couldn't find people to manage their data centers. So it's interesting to see how it all ebbs and flows and how.
I mean, with railway specifically, you're in a colo. You don't hire the hands that replace the drives. You have someone that works at the colo facility that you pay for it, whatever. It's like, it's an outsource sort of thing. Like, oh yeah, I don't have to worry about hardware. It just happens for me, right? Like the day-to-day sort of things. I've been calling this, instead of cloud computing, ground computing, where instead of being on-prem or saying it's edge, or I'm like, no, it's just like stay grounded to like what you need, what your business requires, and then know what it is that you're trying to build against, right? Because right now you were in a cloud and you're like, hey, we can get started here, knowing that eventually our economics are just going to have to be probably on hardware that we own because it's just cheaper for us in the long term. And at some point, you're in a colo right now. At some point, you might need to build an actual data center. Like you might actually have to scale to a size of like, hey, we own a data center now, right? Like that's if we are that big, it's going to be cheaper for us to own the data center than to rent the power, right? And that just is how some businesses grow. Some of them don't, and it's fine. Like you're somewhere in the middle, but like try to stay at the point of like, this is where we're at, or this is what we know we need. And so many people just said the cloud's going to solve all those problems. The cloud's going to be the end all be all. I'll never have to run this again. Let me forget how to plug in an Ethernet cable.
But isn't that like just the levels of abstraction at this point, though? That's why people think about AI. AI is going to be developers and they're going to do all this stuff. Like it's going to take over. Like, people like, and then people didn't like when we got higher than assembly, then people didn't like the next language. That was another abstraction. There are different levels of abstraction. Do you want to run your own hardware? Do you want to just buy your own hardware? Do you want to have no idea what hardware is going on and live in the cloud? Like there are different levels of abstraction, right? And it's like people want to do this is better and that. And I think we're finally going to get to the point where people are going to learn to build what they need and not what's cool, right? You start in the cloud.
I don't know if that's ever.
I hope so. I would like to.
I hope so too. I hope so too.
I would hope so. Because like
there's too many incentives. Like it's a lot of marketing.
It's not just the incentive, it's the hype. Like I don't even think that they like think about it. Yes, because it's like, dude, like you can figure out what you're building in the cloud, get your traffic, go to a colo or on-prem, and all of these things are just picking the right tool for the job. But people want to be like, they have to write these like catchy blogs about like on-prem and all this stuff.
I mean, I like hype. I enjoy hype. Like hype is fun. Or like being part of the hype train is fun, right? It's just like, oh, cool. We're learning something new. I love learning new things. I think one of the dangerous things is when the hype becomes like you have to defend yourself for the hype of like, I chose serverless and serverless is the only way to do everything now.
Yeah.
And they're like, wow, serverless is really expensive. And like, yeah, but serverless is the best.
I think that's different though. That's not hype. That's excitement. Like genuine excitement over learning is fun. Hype is when everything is a hammer and you've lost your whole mind because you've drunk the Kool-Aid and you are so deep in that it's just you want to use the hammer for everything.
Well, and if you know how to use a hammer, like I've used the wrong tool for a lot of things. I used Ansible way too long.
But sometimes you kind of, but sometimes like
I still use Ansible.
Right, it's like it's good for some things, but like
just
I
think Bash is horrible, but sometimes you have to use it because it's the simplest way to do it. Like, but that's not always bad, right? Like if there's multiple tools to do jobs. There's multiple ways that you can get compute power. And sometimes you're picking what you know best because that's what you know and you don't have to spend the time to do it. And then there's using a completely different tool that you want to use for that job.
Can you not believe how many people like reached out to me and they're like, oh my God, like, should we build a colo? And I was like, do you have $5 or $10 million a year of infrastructure spend that you have to like optimize and like, you have you got to pack all these things really tight? And they're like, no. And then I was like, probably not then. Like,
yeah.
Why would you want to go? And they're like, well, it just seems like we could save a bunch of money. And I was like, if you're not willing to like, build all this stuff out and make this massive investment and like wrangle all of that complexity, like it is not free. Like it's not free. You're just paying in different ways, you know?
Like I've heard people like they're just like, and we're gonna pay up front for all this hardware, and it's gonna be like practically free after. And I'm like, at some point you have to replace it. Like that's not how this.
Yeah.
None of this is free. Like it's just picking your evil at that point and what is more sustainable for your business.
It's like, if you heard I think John Carmack has like a rant on like architectural, he calls this like architectural astronomy, where people just like start making like things and they're like, oh, then we could do this. And then the AI is going to do this. And then you're like, but how? And they're
But
like,
isn't
no,
it funny because it's the exact same thing with AI. AI is probably going to make things more efficient. I love when it writes an email for me and it takes a bunch of like cliff notes and it makes it sound like a not neurospicy, like all over the place engineer. But it does like, it's not going to solve the world's problems. Let's just use it for what it's for. Like, it's not that hard.
Have you shared at all how much money you've saved going to your photos? Or
No, because like it's still TBD, I guess. Like
Yep.
we still don't know. We only have like rough estimates. I would
and this
say.
is only, I mean, you were onboarding customers, I think, by the time we recorded this, maybe 3 or 4 months ago. So it's not like a full year cycle to know.
Are you
Yeah.
tracking pretty closely to your expectations? Like, like, are you?
Yeah, I would say we're within about maybe 10% of our expectations. So like
That's
the
pretty
math is still mathing, which is cool,
I love that you
Um,
said the math is still that.
right? So that's good.
It's so real.
Like, it's funny because like, that's like an engineer. You're like, oh, my business is special and like all these other things. And then you look at like this, the Excel sheet where somebody has worked out your business on an Excel sheet. They're like, this is your business. And you're like, no, but it's so much more. And then you're like, oh no, but you can actually just value a business off like a P&L sheet and like go and do that.
And it's not even like
Yeah,
hard
but
No,
you have to just,
calculations.
It's just like you plug it all in and then it goes like this and then you'll do this. And you're like,
but isn't that so true though? Because you like fall in love with this baby that you made, and like you're just like, and I love it so much, and it's so special. But I think you should be proud though, because you made like your business out of like smart plans. Like it sounds like you've really done such a good job like thinking it through, And I mean, with the things that get
we'll
funded
see. We're still really early, but I
in
appreciate
VC land.
Before I switch topics completely, I want to ask one more thing. Was there any surprises along the way now? You haven't maybe done a full year of sales cycle, but like you also hinted in the blog post that you're building like bare metal provisioning, right? Like you're doing Pixies services and doing that sort of stuff. Like those are all things that are kind of solve problems if you look into the world, but never in a specific way. Where there's surprises along the way that you're like, oh, you know what? This is going to take us 2 months of engineering time that we didn't plan on.
Find some wood because like so far not so much. We fucked up the specs on something and I think it cost us $45,000 for like we bought the wrong drives. And then one of our engineers was the guy who spec'd it out. He's like, oh my god, I'm like, this is horrible. Like, how are we gonna figure out? And I was like, we just spent $4 million. Like the 45 grand is like just leave it.
Yeah.
It's fine. So like stuff like that, I would say is like the main thing. We've actually figured out, and we ended up having to buy more of the right drives because the machines ended up working a little bit more efficiently with some of the code. We had some code that was like, I guess we like one of our dependencies was highly dependent on like file system write speeds. And when you go from like cloud like EBS write speeds to like bare
NVMe
write speeds, turns out you get like 1,000x improvement, right?
Yeah.
So we're like, oh, cool. I guess we can pack even more of these things on this instance, so that'll be really, really cool.
I love laughing at every
gonna-
EBS like enhancement of like, look how much throughput we have now. I'm like, what? Like, hold on a second.
I was going to ask if anything worked out better than you thought it would because it's interesting.
Yeah, I would say anything to do with storage so far has worked out better. And like just I don't want to say like long-term storage because we're still like working on that, and it's also like storage is hard. But mostly like just like actual like drive storage and like local storage.
Shifting gears a little bit here now. The reason I asked you to come on shows, we talked about you built your own orchestrator for your applications for customers that are running applications on top. And I forget where I even heard or where I saw that you're not using Kubernetes, you built something else. Can you describe what that is and why?
Yeah. So the reason we built the orchestrator, right? And it follows a reasonably simple premise. If you use Kube and you hit 150,000 pods or whatever that limit is that you're gonna that Kube is available up to, you're gonna have to write a multi-cluster orchestrator, right? So you're going to have to write an orchestrator for that orchestrator anyways, right? So we figured, since we wanted the higher order control and we didn't want to be like beholden to like the cube synchronization loop, we figured we would just like start from scratch and write our own orchestrator if we knew at some point we would just have to write a multi-cluster orchestrator anyways, right? So that's the reason why we ended up going and doing that. The original orchestrator, it's literally just like a Go binary that runs on a bunch of these instances. And it like backs onto this massive like Redis instance. And that worked until it like wouldn't scale anymore. And so now we built it on top of, I believe Scylla, is the kind of like backing storage for all of this stuff now. And we're currently in the middle of transitioning between the like orchestrator v1 to the orchestrator v2, to like go and manage all of the like bare metal and cloud instances. But that's like the main reason we wrote it, right? We want to be like build a really, really quick, like, because we have to do failover, right? For instances, like if they go and like disappear like that, right? And so like we can't actually wait for like, like Cube to essentially say, oh, like we have to replace all these instances and all that other stuff, right? Because that's going to mean downtime for users, right? We also want to be able to do like dynamic scaling and orchestration, right? So like as instances grow bigger, if you have a database instances, we should shift off everything off of those machines for you so that you don't actually have to like say, oh, okay, cool, it's going to go to 8 gigs. And then what do I do now when I like want to move my database? Like your database should be able to just expand linearly until it like runs into something else that we like have to live migrate across those boxes. And by building our own orchestrator, we just get like a higher order of control. Like we understand the runtimes. We've gone through like 3 different runtimes right now. Like we went through like the like actual container D runtime, Podman. Now we're on to like cloud hypervisor. So like we now really understand like how to move these instances around really, really well. And I think like most companies don't really know, or they kind of know, but they don't really know what their core business is, right? And our core business, if we are going to be a business that like manages containers, is to manage containers, right? And so we should take that extremely, extremely seriously, right? If we are using Cube, then like what's our core differentiated advantage between another company that is just going to use Cube, right? So we figured that we would invest really, really heavily in there. And that's worked out well so far.
A lot of what you said reminds me of our conversation with Jazz about Blue Sky's architecture, where they're like a bunch of PDSs are running on instances. They use NVMe storage. Everyone's a SQLite, and they can just pack thousands of them on a box because write speeds on NVMe are really big or really fast. And I think they're using the same Cilia database in there somewhere, if I remember correctly.
Yeah, it's funny. We talked about it. I was like, oh, isn't this thing great? And he's like, yeah, they just made license changes. I was like, oh, how did I miss that? Like, God damn it. And he's like, don't worry, we've got a year to figure this out. And I was like, all right, fine.
But also it's interesting because they're doing just straight up like Docker Compose, right? It's like no orchestration. It's like we just have a bunch of boxes. We know how to spin up a user basically for every person's a database in a website. And in your case, and that means they're a container, but they're not live migrating them. They're not moving the data. They have the hot failovers for a lot of that stuff. Versus in your case, where this is a customer's container, they hand it to you. You don't know what the code is. You don't know how it's going to run or what it's going to do. So you just have to isolate it as much as possible. And at that point, you're using Cloud Hypervisor, which does isolation at the CPU, right?
Yep.
Is there a notion of like mixed workload types if you want to go something like a WebAssembly route, which has, a different type of isolation and runtime, or are you only ever going to do containers from customers in this way?
I think our kind of view as of right now is that like containers are a really, really good primitive for like, I have this stuff that I want to run in this place. WebAssembly is like still kind of like materializing, like you can take it and stuff like that. But I think it's almost a different orchestration problem for like WebAssembly than it is for containers. Like maybe not entirely, but at least in some facets. So at least for now, we're going to like focus on just containers and figure out how we can like dynamically expand and collapse those like down really, really, really quickly with zero downtime, right? Like this is also the point of like writing your own proxy. Like if you write a bunch of these things, then you can actually integrate them kind of all together, right? And so you can kind of use the like TCP as like one big buffer if like something's failing over and you just like shove stuff through your network and then you just like drain it into the new instance. You can do that because you have control over your network, your compute, and your storage, right? And so like diving into all of that means that like you can make those things happen that you wouldn't be able to otherwise if you didn't have control over that stack.
It sounds like a lot of what you're doing is to some degree recreating Lambda, right? It's like you want to be able to collapse something. Like if no customer's using it, we want it to cost us zero on system resources, right? We're going to checkpoint to disk. We're going to say just, we want that RAM back for someone else right now. And we're going to assume that not everyone on this box is using 100% of their allocation all the time.
Yep.
How has that impacted what technologies you use or decide to use next, right? Like you mentioned, you wrote your own hypervisor, but you're taking packages of containers and saying, we're always going to run a container.
Yeah. So I think for us, like mostly the technology is like whatever almost like gets the job done, if that makes sense. So we've used a lot of eBPF on our networking layer because that's what's kind of got the job done, right? So it's kind of been a more kind of holistic team decision to say like which things should we adopt in general, like where are we going to get outsized returns? Sure, we could bring Rust into our stack, but if only one person knows how to like go in and do that, like you're not going to get a ton of benefit, right? So like we made a few bets on technologies, right? Like eBPF, WireGuard. Those are two big ones that I think have been really, really good so far. And so that's kind of more of what informs it is like, what experience do we want to deliver to the customer? How can we get something that's like close enough to that experience that we can go in and sell and then like drive demand through? And then how do we push from close enough to like, that's the experience, I know that sounds like very hand wavy in terms of
I'm actually curious. I learned something this last week that WireGuard's encryption routine is single threaded. And so when you're actually encapsulating packets and you're encrypting them, that is using one core of your box to do that encryption. And so your throughput is going to be limited by as fast as a single core can be. And so you actually want a faster CPU, not more cores, which is, I have seen it in multiple places. And I actually was reading other people that had a similar problem where their network throughputs was drastically reduced. They had, 100 gigabit NICs, but they couldn't get more than like 10 gigabit throughput on WireGuard. Have you run into any of those edge cases with?
I don't know if we have just yet. We probably will. We're very kind of fly by wire in terms of like thing we run into versus thing we resolve. So the moment we run into it, we're basically like, okay, like how do we solve this next problem, right? Like we'll run into like registry scale issues, right? And so now we have to build our own like actual internal custom registry, right? Because like it's just not fast enough. So
container registry.
Yes, container registry. So that's kind of how we've been operating there. And yeah, I haven't run into that one actually just yet. Maybe somebody on our team did, and they've kind of like resolved it. But I don't think so because then you'd have to fork WireGuard, right?
Or commit upstream or something.
Yeah, or commit upstream, right?
Yeah.
So
I probably should have done this earlier. Can you describe what it's like if I'm running an application on Railway? Like if I make a call to that, what does it go through and what does it run on? Like go from outside in and then from top to bottom.
Yes. The what happens when you type cat into your browser of the Railway networking stack.
Yeah.
This is funny because I'm probably the worst networking engineer on our team, and I'm not ashamed to like admit that, but I will try. So what happens here is that we have a bunch of edge network, like kind of edge nodes. So we broadcast an IP on GCP, and now we broadcast. We just bought the IP. It's like 66332211. So we now broadcast an Anycast edge.
Remember, those vanity IPs are going quick.
Yeah, I know, right? So we broadcast Anycast on the edge there. And then whenever you make a connection to it, that will land to an L4 load balancer, which I believe goes and runs either some eBPF code if it's ours or on the GCP like L4 edge that they've got. And then that backs onto an L7 proxy that we've got. So we've got both a TCP proxy as well as the L7 HTTP proxy. We will go and terminate TLS at the edge. We'll go and dump you onto the WireGuard network. And then there's a WireGuard like node for each node, I guess, on the network that's paired together. We go and do some eBPF transform. We've got like essentially like a IPv6 like CIDR block or that we've got. And then we do a transform based on it's like host to container or container to host, depending on like whether it's going in or out. And that'll tell us how to like route the packets to like the relevant instance, right? Those will go to the relevant instance. It'll go inside of your container. Your action will complete, and then it'll get shot back out, do the reverse transform of the eBPF. Shout out to Charth, who's written a blog post. We can link it at some point here on how this works. And then it'll get shot back all through that pipe out to the internet.
So everything internal from your HTTP layer 7 proxy is IPv6.
Yeah. So like everything past the edge network it's all IPv6.
Yeah. That's a good move for scaling for sure.
Yeah.
And then
100%.
what's below that? Like my code got executed somewhere in a container. I ran Nginx, and that is running in a container on top of a cloud hypervisor on top of Ubuntu on top of Metal, or
Yeah, pretty much.
cool.
Yeah.
It's like
It's super simple. You should build one.
Don't tell him that. He will really go build one. You don't like. Did you see what happened when Blue
It's funny
Sky
because, like,
gave in?
No, I didn't. What happened?
He decided.
just
He
I'll
decided.
self-host anything if I think it's a fun weekend.
Then I couldn't like reply to him for 2 months.
I was running my own.
Oh, because you
PDFs.
ran
It's
your
fine.
own blue sky and you backed up all your
It's fine.
traffic.
Yeah, I got a PDFs. It's fine.
It's fine. Happens, Yeah, like all the things together, like you can build them, right? Like, but as we know, like things at scale and like, edge cases and stuff like that, that's a lot of the battle in general, right? So
Which the interesting thing to me right now is the fact that like that, all that network stack is pretty simple, and yet it was still difficult to do on top of it. Like you could do that with EC2 instances, right? And a lot of people do that essentially with EC2 instances. They have their own proxy. They're like, oh yeah, we just run, well, I guess you can't nest the hypervisor on AWS, but you could on GCP. And you can say like, oh, I just run a bunch of this stuff. But you're mentioning that like performance of the hardware is so much better. Like just the power you get
when you try and jam 5,000 instances on a single box so you can get the density that you want to like get that like Lambda-esque experiences where you can like move everything around very, very quickly, that's where you end up with problems. Like at this point, like I think our next bottleneck is like system D. So we like have to go to like Leonard Pottering and be like, hey, can you make these changes to like go and make this like part faster? That's a joke, but it probably won't be a joke.
I mean, like the company I'm at, we don't have system D. Like we took system D out. We're just like, no, like it's not happening. So
Which is interesting.
Totally
because
understand.
You start seeing more and more like these different Linux distributions actually taking pieces of the distro out, and it's just interesting to see how that's going to continue to like move along.
It's super interesting. I feel like there's a whole kind of like thing happening with Linux, right, where some people are like really pro system D, where it's just like, okay, this is the new kind of
which like is on brand, because I feel like people that run Linux like to just, they wanted all the buttons and all so it's like, I mean, it's almost like the Linux religion. Everybody's got their own denomination. It's just wild. Like it's like on brand. Like we saw it coming.
Yep.
I was gonna go so many different directions that I'm not going to. What?
Which is like, it's bad because the things he normally says are very spicy. So when he doesn't say, like, I kind of want you to tell me, but I'm scared. I really want to.
Boring. Like I really like System D for a general purpose Linux system. Like I run Linux on my desktop. I want System D here. System D is great. I think it's fantastic. It lets me do all the things easier than the old init system's good. And I did not like manually numbering and writing bash scripts to
give me the Ansible hammer and the System D hammer. I'm a very happy man. Like, I can do a lot with that.
Yeah, but then in the single use case purpose, I don't want a general purpose thing because it has all the knobs, right? Like that's the point of like ripping out Kubernetes, right? Like Kubernetes is a very general purpose. You can run anything you want.
It's the most general purpose, right? Like whatever you want to run, it will run the thing,
Yeah, but it's not going to be good for a single purpose. Like, hey, we only need these 4 bits. We don't want the rest of it. Like, we're just going to write those pieces ourselves. And that exactly, like, as you go lower in the stack, you're like, oh, I don't want the general purpose thing here. Let me get a single purpose thing. And you move up the stack and you single purpose thing on top too. What do you think is next? Like, what are you going towards, or you mentioned you have like maybe a systemd bottleneck, but like, what's the next architectural thing? Is that a storage benefit? Is that a networking benefit? Is that, I don't think you can get more compute out of, I think
it's mostly going to be storage. I think it's the storage will be the interesting stuff, right? Because right now we're running like some reasonably chunky like Ceph clusters, right, to manage most of our storage, right? And I think at some point like we will probably want to go and build our own storage. I don't know why, but it's like where my brain is going next in terms of like, I think this will be the thing, right? And so probably networking bottleneck wise, we'll probably run into a few like random things. Like we'll probably even run into that WireGuard, single threadedness thing you were talking about. But in terms of like actual like really, really strong meaty problems, I would say that, and then just continued like problems on the orchestration engine, right? In terms of like building basically a real-time operating system, right?
Yeah, and you mentioned you're still migrating from the old to the new currently, so you're still going through that. What is your plans for like scaling up? Like, I mean, again, people also say like the cloud is great because you can just call an API and get more instances. Are you I know you're opening more and more colos or more locations. Are you on this like continual train of like, yeah, we just every quarter we have to order more hardware? Or
Yeah, so it's almost like a continuum, right? So like if you really want to burst up, right? Like we're going through kind of like a reasonably solid traffic spurt right now. Like I think we 2.5x over the last 2 weeks are just like signups. So like I think we're gonna pull in like 100,000 people this month or something like that. It's kind of nuts. But like if we get into these situations where we have to scale rapidly, the nice thing is like we can still take advantage of the cloud like primitives, right? Like they still exist, right? So the way that we kind of want to operate is we do want to kind of like have like one, maybe two, et cetera, kind of cloud partners that we can kind of like almost like burst into, and then order more hardware to kind of like get those like, it's almost like committed use discounts, but like with your own hardware, where we're just like, oh, we have that much capacity. And so how do we move that over, right? So that'll be kind of the almost like capacity planning that'll go into it. But yeah.
Do you feel like your capacity planning so far has been successful? Because it's such a hard kind of equation to figure out.
I'm so glad my desk is wood. I'll just keep knocking it. Yeah, I think so far our capacity planning has been pretty good.
The way you know, like, wait.
Yeah. So I think it's been solid, right? And we also we now have a relationship directly with Supermicro, so we can order stuff directly from them, which is great. So that's solid. And we've got a lot of space in both our colo from a power perspective as well as racks, et cetera. So it's mostly about like get thing to colo, put the pizza box in rack, right? And we've built our own kind of like provisioning and bootstrapping system for a lot of these things. So at this point, it's basically like turnkey in terms of like getting these machines online. So that's quite nice.
I love the difference here with, we've talked to Blue Sky, scaled incredibly last year on-prem. You're kind of like a constant, hey, we have some predictions, we know where it's going. Obviously, when this episode comes out, everyone sign up for Railway and just blow those numbers out of the water. And you're just like, oh, great, now we're in trouble.
Oh no.
But then we also look at like other people like hey.com, right? They're like, oh, we're moving all on-prem, but like they're also like their growth isn't astronomical. It's not, they're like, yeah, no, it's an easy prediction. We run an email service. We don't have like hundreds of thousands of people coming all of the time that we need to constantly scale up. They're like, yeah, no, we just bought a bunch of hardware once and it probably lasts us for 4 years.
We're running a big MySQL database right here and it's going to stay there.
Yeah. And like in those, all those aspects of like, one is just like a steady thing, one is like a continual growth, and the other one was like, oh my gosh, we're growing way too fast. And in every case, it's interesting just seeing how doing a little math up front, doing a little more planning up front, and making sure that you understand like where the constraints are and where you're going to have to scale up. Like some people are like, I don't know anything about my business, so we're just going to do everything in something that's super flexible and just pay for it as we go. And maybe we'll figure out later. And then they kind of get stuck. Yeah,
it's all understanding the constraints. So it's the constraints of the cloud. It's the constraints of hardware. It's constraints of growth. You know what I mean?
Yeah. So many different ways to skin it. I was really, really surprised with the like fact that I didn't realize that Blue Sky was running their own hardware. But then when I talked to Jazz, I was like, oh, this makes a ton of sense, right? Because it was like just so much networking traffic, right? Like, especially if you're doing video and stuff like that, right? It's like, obviously Netflix runs their own hardware for these reasons. So like it makes sense, right? But yeah, it is just like it's benefits and trade-offs, right? So you just gotta
and knowing which parts, right? Because like Blue Sky runs a bunch of pieces in the cloud. Netflix is a huge AWS.
Yeah, I was gonna say Netflix. That's what I'm saying. Like they're so everything was in the cloud, and now they're like everything on-prem, and neither is right.
Neither's right.
And that's where I keep saying that the best thing about the cloud is the marketing department, right? Like they will tell you everyone's in the cloud because everyone has a piece of something.
Have you ever heard any business like not try to sell more?
I think it's just JP Morgan. The only example I hear is all of JP Morgan's like old data centers that they've got. They're just like, that's the example.
Who just moved? Geico just moved on-prem. Like they just like a multi-million deal that they're like, yeah, no, we're going all on-prem, and they moved to their own data centers. But
a lot of these places have always had one foot in the cloud and one foot out, and the most successful of like tech companies are always the ones that know what to use in cloud and know what to use on-prem. Like some of the stuff that Netflix uses is very interesting, and just the way, like, I mean, even Disney Plus, the way that they use DynamoDB for bookmarks, like I would have never pulled that out of my, like, like it's just
the service that went down at lunchtime, you mean?
yeah, but still, nonetheless, like, you know what I mean? Like it's just
I was there. That was a fun day.
the different ways that you can do the same thing,
Yeah.
It's just crazy. Like Netflix is not what I would have picked for using that many cloud services, but
I mean, they have a huge their data distribution is all their own hardware that they put out in
that's what I'm saying. And they
yeah.
also are one of the most fired technical like blog writers ever. Like they do
so
amazing Java. Like yeah,
blog
like
post is
like
excellent. It's like
Netflix is
awesome.
really good at hiring people that are good at what they do.
Yep.
And making them write blog posts.
Yep.
I think more
But-
companies
Paying them
need
a
blog
shitload
posts.
of cash.
But they have to, but they work so well on figuring out like just the way that they made the platform engineering team, and like they do a really good job at hiring really smart people and then letting them do their job well and empowering them to do that job.
Yeah. One of our favorite books internally is the No Rules Netflix book. It's just it's excellent. It's just like I think everybody should read that book, right? Because it really is just kind of like a masterclass in terms of like treat people like adults, give them a lot of autonomy, hold them accountable if they mess up, but like make sure that there's an environment where you can make those mistakes, right? Because that's where you're gonna get most of your returns, right? Like, again, example, guy who built our data centers, right? It's like, yeah, sure, you mess up and you blow $50,000 worth of drives, right? But it's like in comparison to like where it goes, it's like it's inconsequential, right? And you should do that, and that's excellent, right? And you should talk about how excellent of a job they did on that, So
Yeah, for sure. Jake, thank you so much for coming on the show. Where should people find you online?
You can find me on Twitter. I guess it's called X now. I'm Just Jake, so JUST and then Jake.
And we'll link out to the blog posts in the show notes so people can check that out. I do think that Railway's been doing some good blog posts just explaining kind of your growth over time and what you've been doing and kind of those struggles that you've been having, which has been a lot of fun to follow along with, because it's fun hearing from startups doing stuff and just saying like, hey, we're doing something different, right? And it's not, here's how we manage Terraform with TerraGrunt in a different way than you thought we should, right? It's like, no, like the fact that you called out that like Excel is the best programming or development tool that in existence is like, yep, this is exactly how you should start.
Yeah. Funny because like it just works so well. You're just like, was Excel designed for like racks, right? Or were racks designed for Excel? Like which came first? You
gotta put that on a t-shirt somewhere. Like it needs.
Excel was my first IDE, so I mean, it's
great.
long
It's
time.
just-
It does everything.
Yeah.
Did you just say you just hurt my soul? But
Oh, it
just,
was 100%.
Oh my god, why?
Thank you everyone for listening, and we will talk to you again soon.
Thank you so much. This is great.
Thank you for listening to this episode of Fork Around and Find Out. If you like this show, please consider sharing it with a friend, a coworker, a family member, or even an enemy. However we get the word out about this show helps it to become sustainable for the long term. If you want to sponsor this show, please go to fafo.fm/sponsor and reach out to us there about what you're interested in sponsoring and how we can help. We hope your systems stay available and your pagers stay quiet. We'll see you again next time.